Okay, sorry everyone. Last time there was a technical difficulty with my computer and also my mic. So hopefully I fixed it today. And let me know if you guys are hearing anything, like if my mic is not as strong, like if you're not hearing me loudly, or um, I'm getting disconnected again. Okay, so as we said before, right, our classes are divided into, our units are divided into two classes. And on our second day, we do more of the fun stuff. So today is the second day for dynamics. So we'll be doing a quick review, right, of what we learned last time, and also the things you guys missed from the Zoom last time. And we'll do a Kahoot after that, like 15 questions. Then we'll do some practice questions, one of which is a AP style question from previous tests. So it is an actual question made by College Board. Then we'll have a Q&A session. So if you guys have any questions, like you don't understand something, that's the time for you to ask. All right, so I'm gonna go back to the, starting off with what each force is, and also Newton's laws. Okay, so I'll start off with Newton's laws. If you didn't know last time, we went over really quickly, right? The first law is every object that stays in motion will stay in motion. If it's not in motion, it will not stay in motion. So let's say you have a ball, right, and it's sitting on a table, right? If you don't apply a force, it won't move. However, if you have a car, right, and it's moving at 5 meters per second forward, then it will remain in 5 meters per second forever unless a external force is applied. Okay, that's also what we talked about last time about static and dynamic equilibrium. Static equilibrium is exactly what I said before of a ball on a table, right? It stays at rest, it does not move. Dynamic equilibrium is like the car example, right? It is moving with a constant velocity, but because it's not accelerating, we know that there is no net external force. And that's why we always say net external force instead of just force, because it's very specific to the sum of forces, right? So yeah, the second law is F equals ma, right? And we use the notation sigma, the Roman, I believe it's a Greek symbol, yeah, sigma to represent sum, and that also means net. So basically, Isaac Newton came up with this equation using calculus, and he basically simplified it to F equals ma, which is the net force equals the mass of an object times its acceleration. Okay, the third law, every object, for every object, if there is an action or a force, there's always a reaction and an equal and opposite force. So let's say, right, I'm sitting on a chair, right? And we know that gravity is acting on me, but why am I not getting sucked into the middle of the universe? Or I mean the planet. It's because the Earth itself is applying a normal force on me, right? Last time we talked about what normal force is. It's really supporting or resisting that change, okay? So basically, you can think of it like that. Also, if you, I don't suggest you to do this really hard, but if you just, like, run into the wall or push yourself from the wall, right? You're applying a force to the wall, and the wall is also applying a force to you, right? It's just because your mass is less than their mass. That's why you're accelerating backwards, and the wall is not accelerating backwards like Superman. All right. Let's go over about the forces. So last time I talked about friction, tension, gravitational, normal, and this time I would like to add one. It's called the spring force. I'll talk a little more in depth about that. So friction, right? We know that there are two types of friction, static and kinetic friction. Static friction is when an object has not moved yet, right? You're applying a force, it has not moved yet, and that is static friction. Once that object starts moving, as we know, it's like sliding. You can try this at home. If you have like a hallway, a clear hallway, you can start running really fast and wear socks and then just stop suddenly. You'll kind of slide forward. And that's basically your transition from static friction to kinetic friction, right? And we know that friction is a force because in the diagram to the left, right, we know that if you look at surfaces at a microscopic level, right, the surface is actually rigged like a zigzag, so it's not very smooth, and that's why we have friction. All right. And we also talked a little about free body diagrams, right? The black dot in the center of the object represents where the forces are acting on that object. It's like the center. Then we draw arrows relative with their lengths to describe how big this force is or how small this force is. And we also label it with subscripts like Fn, which is normal force, Fs is static friction, the force of static friction. And we'll do a little more practice on drawing free body diagrams as well. Okay, force of friction continued. So we looked at this graph on the right last time, right? About static friction. Basically, static friction changes. So basically, you apply more force, right? So I can apply 1 Newton right now to a box on sandpaper. It won't move yet. But as I apply more and more and more, right, we see this positive trend. At one point, it can't take in all this force. It can't resist it, and then it turns into kinetic friction. That's when the object starts sliding. But it doesn't mean that when the object starts sliding, it doesn't have friction. It still has friction, except it's less, right? And that turns into kinetic friction. So this drop in the graph, right, we see it go up and then it comes down. That drop in the graph is basically the transition between static and kinetic friction. And basically, if we learn about energy in the future, right, if you do an energy analysis of this, this is basically the point where you lose some energy in your system. Sometimes that's due to like sound, also the texture, things like that, okay? We also learned that force of friction is equal, the equation to force of friction is mu times n. And I believe some of you guys in the chat said Pokemon mu. You can pronounce it as Pokemon mu as well. I'm fine with that. And so mu actually has two types of mu. We have mu subscript s and mu subscript k. Mu subscript s is static friction, right? The coefficient of static friction. And mu subscript k is the coefficient of kinetic friction, all right? So we have two types of frictions, okay? Now, the bottom left diagram also is a little diagram of how, right, something transitions from static friction to kinetic friction. Yes, that is thermal energy. That's loss of thermal energy. So things can be lost through the sound, right? Heat, right? When you're rubbing your two hands together, you're losing energy like that because you're basically dissipating it into your atmosphere. And also, we talk a little about this in energy conservation, but later, if I have time, I might make a momentum course, a continuation of this intro course that will talk about energy and momentum. And I think the closest thing, I think on this earth, you really don't have any conservative systems. I think the closest system you can get to is like a billiard ball, if you guys have ever played pool on your phone or actually on a table, the billiard balls, when they collide with each other, you hear that sound, right? And that's also how energy is being lost. But I think the closest system to getting almost zero loss in energy is probably pool, playing pool. Okay, so normal force, right? Normal force we talked about last time, right? I'm sitting on a chair, right? And we know there's gravity acting on me, but because I'm not getting like sucked into the center of the planet, right? We know there's normal force. Normal force is always perpendicular to the surface, right? So then we talked about inclines, right? What if you had a surface that was angled, that was tilted, right? It would still be perpendicular, except we'll talk about later how the normal force changes, right? Its magnitude. On a flat surface, we could assume that the gravitational force, the weight is equal to your normal force, right? Because the object is not accelerating downwards. But because it's on an incline, it can accelerate downwards. And that's why normal force is usually less than the force of gravity. All right, tension. So tension is also a force, right? We don't really have an equation for tension. Tension is usually a magnitude with direction. We usually solve this using a system approach or object approach. I can show you later also within practice, one of the practice questions we'll be doing. So there is no equation for this. We usually use isolating a variable to find tension. And we also notate it as F sub T, okay? Gravitational, okay, gravitational, we talked about this many times, right? It's equal to mg, which is your mass times your gravitational field strength of where you are. That's why you see in this diagram to the left, right? The gravity on the moon, the field strength is very small compared to on the earth because it's smaller in radius and also in mass. and that's why your weight also changes. All right. And also in the right image, it also shows you how gravity works, right? Everything pulls towards the center. But because when we solve AP physics problems, we're not dealing with the entire planet, we can usually assume that it's going downwards, though theoretically it's towards the center. Okay, 9.81 meters per second squared, right? This is the gravitational field strength of this planet. It's an average calculation done by all scientists. So basically, if you go around different planets on this world, you can actually get different measurements, right? Because let's say you're on Mount Everest, right, and you're calculating the gravitational field strength, it's going to be less because your radius, apart from the center of the planet, is less because Mount Everest is so high, so that creates a addition in altitude. Whereas if you're on like a flat surface, like at sea level, your measurement of the gravitational field strength will be higher. So it's an average calculation. Okay, some of you guys left early last time, I understand. So I'll be going on what is inertia. Inertia is basically a resistance of a physical object to change its state of motion. As you can see on the right picture, right? If you're driving, and then suddenly this car in front of you stops, and you press the brakes really hard, your body starts to lunge forward, right? And that's because of inertia, because you have mass. Inertia depends on mass, and this is why if you have like a bigger ball, like a bowling ball, it's harder to stop it as compared to a balloon, right? A balloon, you can just hold it, but a bowling ball that's going towards you is really hard to stop it because it has more inertia, and that inertia is because it has more mass, all right? So static and dynamic equilibrium, I went over this. Static equilibrium is when an object is not moving, right? And its acceleration is equal to 0. Dynamic equilibrium is when acceleration is also equal to 0. However, it has a velocity. So it can be moving, but has to be at a constant velocity. Okay, inclined planes. I don't have the time for a derivation, but I would definitely go over this. Okay, what altitude on Earth is a gravitational field force the strongest? I would not say the gravitational field force, probably the strength. I would say definitely somewhere close to the Earth, like below the sea. Somewhere very, very close to the sea, close to the center of the planet. The closer you are to the planet, the more gravitational field strength you have. And that's kind of how black holes work, right? You have this horizon where once you pass it, you get sucked into the black hole. But if you're outside the horizon or its gravitational field strength, you don't get sucked in. And the closer you get to the black hole, the more force you experience, and that's why you accelerate faster. That's why if you're like around a black hole but you're really, really far away, you might feel some pull, but it won't be as strong as if you're right next to it. Okay. Sine and cosine, it is a trigonometric ratio. I know some of you guys don't know trigonometry, but you should definitely know sine or cosine. If you have a scientific calculator, I would really recommend. There's a sine button, cosine, and a tan button. Basically, if you press sine, it gives you parentheses and you put it in the angle. I can't go over it, but I did put a link in the ed chat about trigonometric ratios. Sorry about that. Okay, so mg sine theta is I usually refer to it as FG parallel, and FG parallel is basically F sub G with two vertical bars. That means that it's the force of gravity that acts parallel to the inclined plane we're talking about. Okay. Why we use this? So basically, if you have FG parallel, you know FG parallel, the magnitude, right? And you want to calculate the time, the acceleration of the block at a specific time. So what you would do is you would find the acceleration using Newton's second law, F equals ma. You divide it by the mass of the block. You get your acceleration, and using that acceleration, you can do many things with the kinematic equations, right? You can find the time it takes for it to come down. You can find the distance it can travel at t time that you decide yourself. Mg cosine theta is basically how we use to find the normal force on an inclined plane. Remember last time I said because if a block is on an incline, the normal force is less than the force of gravity. And the reason why is because you have this cosine theta. And basically what cosine theta does is, in math, basically usually cosine theta is less than 1. And if you're multiplying something less than 1, you're basically decreasing its value. And that's why the normal force is always less than the force of gravity on an incline. You should memorize this equation, mg sine theta, mg cosine theta, because you'll be using it on the Kahoot as well. So just remember, mg sine theta is the equation for FG parallel, is used to find the force of the block on the incline, like parallel to the incline. And then mg cosine theta is used to find the normal force on a incline. Okay. Okay. So now let's go back. So spring forces. Um, spring forces uses this equation, as you can see on the left diagram, F equals negative kx. I usually just use kx. Some people use negative k. It's for mathematical calculations. What k is, it's like a constant. It's kind of like Pokemon Mew, or like the Mew we're talking about for friction, but it's a constant for spring. So I have a couple springs right next to me. So I have a really tight spring right here, as you can see. And basically, if you pull it, it's really hard to pull. And that's because the K, or the constant we call K, is really large. Compared to if I have like a spring for a pen, like a click pencil, or a less condensed one, like these, right? If I pull it, it's really easy, right? And that's because the K constant for the spring is less than the K constant for the spring I just showed you. And so basically what this equation is saying is, okay, and also x is kind of like, x is the displacement. Remember we talked about vectors, difference between distance and displacement. Displacement is the change of an object's position from its initial position to its final position. Okay, so as you can see in the left image, right, if I have a spring with a block connected to it and I'm pushing it in, I'm basically displacing the spring this distance, this x distance that I called. Okay, it's the same thing. Like basically, you can use this, test this out yourself too. If you have a pen, right, you're clicking in the beginning. It's not that you don't feel that much force, but if you're clicking all the way to the bottom, you feel a lot of force. That's kind of basically how it works. So K is like a constant. Its units are Newton meters. Newton divided by meters. Okay. And basically, K is like a concept of how strong this spring is, okay? And then X is the displacement. So basically how you find a spring force is you take the constant of that spring and you times it by the displacement, that magnitude that you displace the spring by. So basically, if you displace the spring more, you get more force. If you have a spring that's more, that has a higher K value, a constant, you get more spring force as well. Okay. Okay, so I'll be going a really quick practice question. This is on Kahoot. Our Kahoot is relatively, it's more complex than last time, but it is shorter. It's like 15 questions. And this is a question I think might be a little troubling for some of you. So I'm gonna run it one time before we start the actual test. So this is not the exact question. It uses the same diagram. However, the thing we're trying to find is different. What we're trying to find is the force of the force applied that we need. So this red arrow, right? That's the force that we need to apply. We're trying to find that. Okay. So if you guys can put in the chat, it will be really helpful. Just put in the chat, what do you think I should draw for the free body diagram for this 20 kilogram block, other than the force applied already, which is already drawn. Just specify what direction of the arrow that I should draw, and also its relative length. Actually, you don't have to think about relative length. Just put in the chat what arrow, like the name of the force and the direction of which I should draw it. Normal gravitational friction. Okay, we can neglect friction. You guys, we don't have to care about friction in this scenario. Okay, I see gravity and normal. That is correct, because this block is not right. It's not flying downwards or upwards. It's just moving to the right with an acceleration of 2 meters per second squared. Okay, so I know there's a gravitational force. What direction should it be drawn? Down, up, left, right. Which way? Down. Okay, yeah, down. And what should I draw it as? What's the variable I should denote force of gravity as? Fg. Great. Okay, what other force do I have? I saw you guys put normal force. Fn, okay. And how long should I draw this arrow with comparison to my other forces? Should it be equal to the length of Fg? Should it be equal to the length of the force applied? Should it be greater? Equal to gravitational? Okay. Yeah, so that's correct. Sorry about this drawing. Just assume that this is basically the same length. Okay, what other force is there? We have this 20 kilogram block and it's connected to by a string to a 10 kilogram block. What other force do you think there is? Tension. Okay, that's a very good guess. I would like to see what other people think as well. Remember, I said string. So think about what force is correlated with string. It's not a spring, it's a string. Strings don't really have K constants because they're not really stretchy. Just think of it as a very tight rope. Okay, Brian Way is correct. It is tension. What direction should I draw tension as? Left. Okay. Should it be greater than the force applied, or should it be less than the force applied, or should it be equal? How long should I draw this arrow? Less. Okay, I see a less. Any other answers? Equal. Okay, I see it equal. Less. Okay. Also, if any of you guys are raising your hands or in the cameras, I really can't see it because I'm sharing my screen right now. So I would, if you could put it in the chat, your answers, it would be really nice. Okay, I see some equal. Why do you think it should be equal? I want to hear from you guys. Why do you think it should be equal? Let me just try to unmute. So if you, okay, try to raise your hand in the participant section and explain why you think it's equal, why you think it's less than, why you think it's greater than. Explain your answer. You can always put in the chat, or you can just raise your hand in the participant section and I will unmute. Yeah, that's really weird. Don't you guys want to explain your answer? Why you think it's less? Why you think it's equal? Why do you think it's more than? Okay, so the question I'm asking, just to clarify, is how long should I draw this arrow, right? We already know that we have Ft, we have force of tension, and we know that it's going to the left. But how long do you think I should draw this arrow as comparison to the applied force, which is the red arrow? Do you think it should be greater than the length I draw with the red arrow? Should it be less than the length of the red arrow, or should it be equal to the length of the red arrow? Less. I would not say, I wouldn't say because 10 is less than 20. Think of it more as the net force, right? We know that Isaac Newton came up with his equation in his second law. Net force equals mass times acceleration, right? So in order to have a net, you need to have a difference, right? You need to have something bigger than the other. That's where you get that net from, right? It's like depositing money into your bank account. You have $10 you deposit, but you withdraw $5. Your net income or your net profit is $5. And we know this object is accelerating to the right. Yeah, you can unmute, just raise your hand, please. Okay, for the sake of time, I'm just going to explain why. Because I have a lot planned later and I don't want to waste too much time on this. It is left. It can, okay, just, yeah, here.
I think it's left because the force because the force bringing the 20 kilograms to the right. I mean, what I said earlier was because the 20 kilograms is more than the 10 kilograms, but because the force can pull the force, the net force is like, because it can pull the one on the left. Never mind.
I appreciate you for trying. I really do appreciate your participation. You are kind of close. It doesn't have to do with the mass. Don't think of it as the mass. Think of it as just this object. Right now, I'm just talking about this object. Don't even think about the 10 kilogram. Okay, are you talking about like, because this block is greater than the 10 kilogram block, so its force should be greater than the I'm not even sure if you said about the magnitude, because I was kind of asking about the magnitude, but it was a good try. I agree totally with Richard Varshall, if I pronounce your name correctly. It is accelerating. Because it's accelerating from Newton's second law, we know that the red arrow has to be greater than the FT, right? We are doing Kahoot, but after this question, because there is a question on Kahoot, and I don't want you guys to get puzzled when we get to it. Okay? So basically what we would do is we would draw this as FT, but it would be less than the applied force. Okay. When we have tension, right? When we have a rope and we're pulling tension, we have a force applied on the right, and we also have a force applied on the left, like this, right? My hands are applying a force this way, and my other hand is applying a force this way. But what's really happening inside the rope is that it's resisting it. It's resisting my force. And so the force diagram should actually look something like this. The arrows are towards inwards, right? I'm pulling outwards, but the tension inside is keeping the rope from splitting, and that's why it's going inwards. So similarly, we can draw this rope diagram as this. Okay, so now let's move on to the 10 kilogram block. Tell me in the chat, right? Everyone that wants to participate, please put in the chat what forces do you think should be acting on this 10 kilogram block, and the direction and the magnitude, and how long should I draw those arrows at, compared to the 20 kilogram block. FG, FN, FT, okay. Can you be a little more specific? FG, right? How long should I draw FG compared to the 20 kilogram FG? Half, exactly. Okay. Nailed it right on the head. How about the FN? Same, okay. We have also half FN. What other force is there? FT, okay. FT, how long should I draw FT as compared to the FT here? Half? No, not really. Equal, yes, it is the same. Because the tension is holding both blocks, right? And it's one rope. It's not like two different ropes. It's one rope. So the tension is equal on one side. If I put it half, right? If I put it half, then the rope would split because the force is uneven. Okay? So in the Kahoot that I'm about to show you now, there is going to be a question at the end that will be asking you for the force of tension. How do you calculate the force of tension? What you would do, I'm going to give you a hint right now because not all of you guys have learned algebra yet. What you would do is you would draw the free body diagram again, right? And this time, I'm giving 4 minutes for this question. Okay, what you would do is you would find out, they would tell you the applied force, okay, the red arrow, and you draw your diagram, right, for the 20 kilogram block. And then you know that the net force, F, is equal to MA, right? This is sigma. Okay. So you would basically put F applied is minus FT is equal to MA. And this M is only for the 20 kilogram block, okay? So you would take the F applied and minus the FT to give you the mass times acceleration. But the thing is that you don't know the acceleration and you don't know the tension, right? So what you would do is you would write another equation for the smaller block. And you would do the same thing, Ft equals ma. But this m is the small n, is m sub 2. So what you would do is, depending on if they ask you acceleration or if they ask you for tension, you would isolate that variable. So let's say they're asking you for tension. You would just take m2a, since you know ft on both sides is equal in magnitude, you could substitute this value into this equation. So you would get, okay, let me just rewrite everything. F t equals m2a, right? And we know that F applied minus ft equals m1a. We don't know ft, so we could say F applied minus m2a equals m1a. And the acceleration will be equal on both sides because it's a system, right? It's one block point. You can't have one object accelerating at a higher change than another block, right? Or else the system would just break apart, right? It's pulling together. So the acceleration is the same. So depending if they ask you for tension or for acceleration, this is basically how you do it. You would isolate the variable. If they ask you for ft, you would just divide both sides by m2 and move, isolate acceleration. And then you sub this equation into acceleration here. All right. M1 is the bigger block, is 20 kilograms. M2 is the 10 kilogram block. All right, so I'm gonna stop talking and I'll leave the rest of the time to you guys. So please get a calculator right now. And also make sure that you're in degrees mode and you have a scientific calculator. Don't get like the ones with plus, minus, the basic ones, the 4 functions. Get one with a scientific. If you don't have a scientific, you can always go on Google. Just to use Google calculator, and make sure you're in degrees mode, and they have sine, cosine, and basically everything. And the way you would use sine is and cosine is you just press sine, and then it'll have a parenthesis, open parentheses. You put it in the angle, you close it with the parentheses, and you take that and multiply it by mg or whatever you're trying to find. Okay. Would you guys like to play team mode or
Team.
individual?
Individual.
Individual.
Okay, so it seems like not all of you guys like working together, but that's fine. I'll just make classic. want sound or no sound? It's kind of half-half right now. Okay, I'm just gonna put no sound for now. We all have 20 players. We have 33 participants. Okay. Can you guys hear me perfectly right now?
Yes.
Okay. And is it glitchy?
Yes.
It is glitchy. Not
Tiny
really.
bit. It's a little laggy.
Okay. I turn off the sound so that hopefully that will help. And I'm gonna mute my mic so hopefully that doesn't make the game glitchy. All right. We're starting the game in 10, 9, 8, 7, 6. Oh yeah, and also whoever is Joseph Chai, I would really recommend you change your name because you know it's your if you get first place, like it's not me, it's obviously another person. But okay. 5, 4, 3, 2, 1. All right. Oh yeah, also if you guys don't have a piece of paper or a pencil, try to also have that right now. I'm gonna after this question, I'll give you guys like 20 seconds to get a piece of paper and some and a writing utensil.
What is the
because
equation for this again?
Newton's second law. You should know that. Actually, it's I'll give you a hint. Everyone a hint. It's net force, right, equals mass times acceleration. So how do you find the acceleration if you know that the net force equals ma? What do you do to both sides? Okay, anyways, I was saying try to get a piece of paper and a writing utensil because you will need to draw free body diagrams and make more complex calculations after later. Oh yeah, and also um if we have 22 part, do we have 22? Okay, basically, if the time runs out or if the time is too long, if you guys all finish early, I'll just press skip. So you guys don't have to waste that time. But yeah, I'll be giving 20 seconds right now for you to get a piece of paper and a pencil or a pen. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, back into the game.
Don't touch the answer.
Oh, I'm not. I'm just looking at other stuff. Okay, that was a pretty time-consuming one. The answer is FG parallel. I mentioned this last time. FG parallel is F sub G with 2 bars or vertical bars, and that's basically the force of gravity, the component of gravity that's parallel to the incline, right? So if the force of gravity, right, it's kind of like the component of gravity that's pulling this object down, right? If you have an incline, you put a block on it, it's obviously going to fall down. But if you have friction, and friction can counter that component of gravity, your object won't move. And that's why the FG parallel has to be equal to the force of friction. So let's move on to the next question. Okay, I kind of said this before, but basically on an incline, because it's an incline, it's not a flat surface. And that's why when you do mg cosine theta, right? Mg cosine theta, when you times it by cosine theta, and cosine theta is usually less than 1 if you use any like other equation. Don't quit, obviously, like this is just a game, but it's for you guys to, it's also testing your time management and also uh, how you're doing your work as well. But if you basically, what I was saying before, when you take cosine theta, right, you times it by mg. Mg is your weight, and if you're timesing something by less than 1, it's going to decrease, and that's why weight is greater than normal force on a incline. All right, next question. just a hint, these next two questions will all be on Newton's laws. So it tests if you really memorize them and study them on your own. Okay, at least no one put fourth law of motion because there really is no fourth law of motion. Okay, great. Oh wow, only one person got it wrong. That's really good. Think of what force is equal to. What is
The thing is
force?
very slow.
It's laggy?
The screen. My phone is like already on the answers, but it still hasn't like put the question up sometimes.
Okay, I'm gonna try to re-share this and see if it fixes the problem.
See, like right now, it's already saying it's already giving me answers, but like it just barely gave a question.
Wait, I made a new share. Is it happening again?
Not now, no.
Okay, good. Okay, the calculation was actually pretty simple. What you had to do is just plug in mg cosine theta. Sorry, wait. Oh yeah, mg sine theta. And mg, they already simplified it to 100 newtons, right? We know that the units for force is newtons. And so if you have 100 newtons, you just have to take that and times it by sine of 30. Okay, next question. Just a hint, if you're kind of confused, you could just look at the diagram, the B diagram. It literally draws out the entire free body diagram for you. And try to think back of what we learned about inclines and normal forces. Also, if you're confused if your answer is negative, don't worry, because G is negative 9.81. So if when you times that by negative M, it cancels to positive. Ryan, stop giving correct or wrong answers. It's not nice. Yeah, give everyone a chance, you know. If you want to say the answer, say it after the question is done. Okay, thank goodness no one put superhuman equilibrium. Last question. This is the question I've done a run over with you guys in the slides. So I will give you 4 minutes for this one. Get your paper and your pencil ready, and okay, let's tackle the problem. Okay, and just if you're confused, the 9 kilogram is for the bigger box on the right with the capital M. The 6 kilogram is for the small m on the left. Okay. You guys don't have to rush this problem. You still have about 2 minutes, 2.5 minutes left. Try to make sure if you have extra time, double check your work before you submit. One common mistake I made was I rushed a lot in my physics class, and basically I made very silly mistakes, I would say. So definitely check your work if you haven't done it yet, and submit when you're ready. About a minute left. Twenty seconds. Five seconds. Okay, nice. Seven of you got seven of you guys got it correct. So yeah, here are the winners. Congratulations. Okay, congratulations to all of you guys. Okay, so now I actually planned for you guys to do a practice question, but since it is past 3 o'clock, if you guys are interested in doing the practice question, I'll be staying afterwards. I know some of you guys have other wave lessons or other stuff to do, so I am dismissing you all now. But if you are interested in doing the practice question or any questions you have, I am staying afterwards. So if any of you guys want to stay, it's fine with me. Yeah, I will be posting my slides as well, so you can see them. It's just like if you're doing it here, I could monitor like what you're doing, and if you have questions, you could just ask right away, and like I could help you easily compared to if you were on it. Okay, the last question on Kahoot. Would you mind staying like 5 minutes after everyone leaves, so I can explain to you? Okay. Yeah, if you guys have any questions, um, feel free to stay. You know, like I'm here for you guys for your help. And also, if you have time, we'll also do a practice question together, and you can choose if you want the college one or the AP style one. Yeah, no problem.
Thank you. Bye.
Yeah. Okay, so I'm assuming the rest of you guys are staying because you have a question or you want to uh, do the practice question or you want to get an explanation for the Kahoot questions. So I'll start off with Xiang's question about the last question on Kahoot. I'll share my screen really quick. Okay. Actually, I think I could do share screen. Okay, so this practice question, right? The only difference compared to the one I showed you is that they ask you for the force of tension, right? And I believe, let me just annotate. I believe this one was 9 kilograms, right? This one was 6 kilograms. And the force was 30 newtons, right? Okay, so the way I would solve this problem first, right, is drawing a free body diagram, right? So we have a dot in the middle, right? We know there's a FG, and we know there's a FN that's equal in magnitude. We know there's a force applied that is 30 newtons, and we also know that there's a force of tension, right? Because there's a string. Okay. They don't tell you the acceleration, but they do tell you the applied force. Okay? Sorry, I have some background noise, but basically, you have 30 newtons, right? And remember, I talked about the equation you could draw before, which is basically, for the first diagram is F sum equals M1A, right? And this is M1, and this is M2. Okay? So we know that the net force, right? The net force is equal to, in this, for M1 is F applied, which is 30 newtons, minus ft. Okay? And then we basically set this equation equal to m1a. Okay, now for the second free body diagram, right? We know there's the fg, that's half of the first one, and the fn, same in magnitude, but opposite in direction, and we have a force of tension. And we know that the force of tension from the small block is equal to the force of tension to the right block, right? Because it's the same string, and if the forces were different, the spring would basically break. So, I mean the string, sorry, I keep on saying spring, I don't know why. Okay, so we know that for the second equation, F, sum of F equals M to A. And the only force that is a net force, right? The normal force and the gravitational force, they cancel out. So that's equal to 0. So the only net force we have is in the x direction, and that's Ft. So that's equal to Ft. Okay, so now we need to find the tension force, right? So we know that the acceleration is equal, and we know that the force of tension is equal. We just don't know what their values are, right? So we could take this equation, m2a, and substitute it into this equation. So we get F applied minus m2a is equal to m1a, right? Now, wait, I'm sorry. We're finding tension, right? So basically what I said before is you divide both sides by m2, and your a equals ft over m2. Okay, then you would not substitute that in ft. You would substitute that into a. Sorry, m1a. This variable. Are you lost right now, or do you get what I got so far? Like, so I basically drew my free body diagram for both blocks, right? I found out, I wrote equations for both blocks, right? What t is, and the net force for m1 and the net force for m2, and I set them equal to ma, right? Newton's second law. Do you get what I'm at right now so far? Yes. Okay. So basically, because we're finding tension, you don't actually want tension to be isolated. You want acceleration, because acceleration is in this equation. Okay. So what you would do is, let me just clear some space. So basically, what would you have is F applied minus Ft equals m1 times Ft divided by m2. Okay, so we don't know Ft, and but we do know m1, m2, and F applied, right? So what we could do is we could basically isolate Ft. So what you would do is add both sides by Ft, so you get F applied equals m1 Ft over m2 plus Ft. Now what you could do now is factor out Ft. So now what you would have is, let's erase this. You would have F applied equals m1 over m2. Sorry. Actually, you would have to add something else. You would have to add plus 1 ft. And then you divide both sides by m1 plus m2 plus 1, right? parentheses, and then you have all your values and you can solve for f2. Your final equation would be f pod over m1 over m2 plus 1. Okay, and that equals your f2. So it was 30 newtons, right? And we know m1 is 9, so 9 divided by 6, which is m2, is 1.5. 1.5 plus 1 is 2.5, and 30 divided by 2.5 is 12. So the answer was 12. Does that make sense? Okay, would you guys be interested in doing the practice problem, or you guys have something else to do? Because I feel like I could help you guys more out on a Zoom session compared to on Ed, because on Ed you have to text and stuff, but on here you could solve, and if you have a problem, you can just ask me right away. But I'll just show you a glimpse of what the practice problem looks like. So this is the first one. It is from a college textbook. It's kind of like a net force problem, also like a acceleration, right? Dynamics. And then we also have a college board style question, a little more complex, but I think we could do like the first 4 parts together. Well, which question would you guys like to work on? The first one, okay. Okay, so the first question is basically asking you, right? There's a diagram to the left, right, of a boat, and it has a propeller, right? And that propeller produces, oh yeah, no problem here. And that boat basically, yeah, no problem. And the boat basically produces a F prop, which we denote as F sub prop, okay? But then we also know that because there's water, right, there's some sort of resistance to that force. So, so basically, okay, the question is an airboat with mass 3.5 times 10 to the second power kilogram, okay, including the passenger, has an engine that produces a net horizontal force of 7.7 times 10 to the second power newtons. Okay, so one way that I like to be doing like solving physics problems is I write everything out, all the givens. So they tell us the total mass, right, is equal to I would just say 3,500 kilograms, right? And then our force equals 7,700 newtons. And that's a net force, net horizontal force. Okay, so part A is find the acceleration of the airboat. Okay, so that's very easy. What we would do is we use Newton's second law, right? The net force equals the mass times acceleration. Right, and we know that it's a net horizontal force because it tells us. So what we do is 7,700 divided by 3,500, right? We just divide both sides by m, and m is 3,500. So your acceleration is 7,700 divided. Actually, you should solve this problem. I shouldn't be solving for you, but I should help you along the way. But yeah, try to solve, and after you found the acceleration, you can tell me, or you can just unmute yourself. I'm pretty sure I can. I'm pretty sure. Yeah. Okay. I'm pretty sure you can unmute yourselves now. Okay, equals, right? Yeah. Okay, so we have 2.2. And what's the units? What's the units for 2.2? 2.2 what? Okay, great. Meters per second squared. Okay, sorry about that. Okay, so part B, starting from rest, how long does it take the airboat to reach a speed of 12 meters per second? Okay, when the problem says starting from rest, it means that the object is basically static, which means that its velocity equals 0 and it could or could not have acceleration, but its velocity will be 0 because it's not moving. So the way you would solve this problem is using a kinematic equation, right? We learned last time about the different kinematic equations. I can write them out again for you guys again, but try to solve the problem using a kinematic equation. So we have Vf squared equals V naught squared plus 2a delta x. We also have delta x equals V naught t plus 1 half a t squared. We also have Vf equals V naught plus a t. Okay, so the hint I would give you is use a kinematic equation. Find out what givens you have, what the problem tells you, which equation you can use, right? To make sure you don't have two unknowns, you only have one unknown, and then solve for that variable. So after you're done solving the problem, just put your answer in the chat. If you have a question, you can just raise your hand or unmute yourself. Yeah, okay. So Vf, V sub f is the final velocity. Okay. V sub 0 is, I usually call it V naught. That's how my teacher pronounces it. It's basically the initial velocity. Some physicists, they also use V sub I, which is V initial, which is velocity, the initial velocity. A is acceleration and delta x is change in displacement. So like it's basically displacement. So if an object moves like 10 meters, it displaces by 10 meters, that's your delta x. And be very careful, delta x is not distance because you could have a object go 10 meters forward and 10 meters backwards and the distance will be 20 meters, but the total displacement would actually be 0. So yeah, be careful of that. If my handwriting is kind of confusing, I'm just gonna find a online image for the equations and I'll just put in the chat for you guys. Yeah, that's the link to the kinematic equations if you can't read my handwriting. Did you guys solve the problem yet, or do you think you just want me to go over it? Okay, so before I said you basically choose a kinematic equation, and in the first the kinematic units, I talked a little about the equations and how to use them. So as you can see, the first equation does not have time. It doesn't have the variable time. So if the question is asking you, or they tell you a time variable, or they ask you about time, you don't use that equation because you can't find time using that equation, right? You can only find the final velocity, the initial velocity, the acceleration, or the displacement. Okay. Second equation. Second and third equation do have time, right? You have the t variable. However, the third equation is different from the second equation in that it doesn't have displacement, right? It doesn't have delta x. So if your question is asking you about how far does this object travel, or it tells you the displacement in the beginning, you don't use those the first or second equation. You use the third equation. So in this problem, they ask you to find how long does it take. And how long does it take is asking basically for time. So you can eliminate the first equation because there is no time variable. And they also tell you that the initial velocity, it starts from rest. So its initial velocity is equal to 0. So you could either use the second equation. Actually, which equation do you think you should use, the second or the third one? Third, okay. You could use the second. It's just very complex. You have to go through a lot of more analysis. And because the problem doesn't tell you, they're not asking for the distance, and it doesn't tell you, first of all, it's not asking you for the distance, and second of all, they don't tell you a distance. So you would actually not use the second equation because you're just making yourself, basically giving yourself a hard time. Third equation is correct because, right, they tell us the final velocity is 12 meters per second, right? And it tells us that this boat starts from rest. And when it starts from rest, we know that the initial velocity is equal to 0. So basically, you could just cancel out V naught and just say VF equals AT. And we found the acceleration in part A, right? It was what, 2.2 meters per second squared. And so basically, you just find time by dividing both sides by acceleration. Does that clarify something? Does that clarify the question for you? Okay, so we know that we now have to use the third equation. So yeah, just solve for the time variable now. The answer is close to 5.5. It's not exactly 5.5. Yeah. Usually, if you guys, just a question of curiosity, are any of you guys like high school students? Or like middle school? Does not yet mean 9th grade? Okay, so that's basically high school. So are you planning to take AP Physics next year for Rachel? Okay, yeah, that's basically what I did also. I took AP Physics in sophomore year. How about Angeline? What grade are you? Oh, you're going into high school. Okay, yeah, this course will definitely help you. If you're either if you're taking physics, regular physics, or AP Physics is definitely going to help you. Okay, so getting on. So basically, do you guys ever learn about significant figures, like rounding significant figures? Have you ever heard of the term? Okay, if you take chemistry, you'll learn about it, but basically I'll give you an overview. Significant figures is basically how mathematicians, yeah, basically, and scientists, they make calculations. They want to make everything precise and also consistent. So basically, since we see this problem, right, with it's to the hundredths place, right? It tells us 7.70 and 3.50, right? You might be asking yourself, why don't they just say 3.5 or 7.7? The reason why is because they use significant figures, and significant figures is basically making sure that all your calculations are rounding to the same decimal place. So since they have 7.70, we usually round to the hundredths place in this question, unless they have they give you a value like 3.501 times 10 to the second kilogram, then you would have to round to the thousandths place. So for these questions, for the answers, just always round them to the hundredths place. Typically is always like that. Okay, yeah, so 5.45, I would round it to there. So Angeline, you got 5.45. How about Rachel? Did you get it yet? Yep, okay. So let's move on to part C. After reaching that speed, the pilot turns off the engine and drifts to a stop over a distance of 50 meters. Find the resistance force, assuming it's constant. Okay, so we know that it tells us a 50 meter, so we probably might have to use a kinematic equation. I'm not sure yet, but they do tell you a distance. And they tell you the resistance force. So these kinematic equations, they don't deal with force, but you could use them after you find your acceleration. And the way to connect forces with kinematics is using Newton's second law. Okay, so it says that a net horizontal force of 7.7 times 10 to the second power newtons. Okay, so that's the net magnitude. After reaching that speed, the pilot turns off the engine. Okay, and it says the pilot turns off the engine. That means that it doesn't, the engine itself does not produce a force anymore. Okay, so the only force is the resistance force, and drifts to a stop over a distance of 50 meters. Okay, so basically in this problem, basically this boat, right, it's accelerating, right? It reaches 12 meters per second. And after it reaches 12 meters per second, it turns off its engine and it just drifts. Okay, so the way I would probably use to solve this problem is find out the acceleration that this resistance force creates using Newton's second law. And then basically what you'll do is you'll take the resistance force and divide it by the mass to find the acceleration. And sorry. Actually, what do you guys think? I actually want to hear from you guys. What do you think? How do you think you could solve this problem? What do you think might be a good step? Okay, let me just annotate everything for you. So part C, right? So we know that V initial is equal to 12 meters per second, right? You're kind of close using a kinematic equation. You are right using a kinematic equation, but the second one is not correct. The reason why is you don't need time, right? You don't need time for this equation. They're not asking you for time, and they're also they don't give you a time variable, right? They don't give you a given for time. So why would you need to use the second version? But you are correct. Using a kinematic equation, that is one way to go. The first thing I would do to solve this problem, if I have no idea what's going on, is write out the givens. Okay, they tell us that the boat reaches 12 meters per second, and then it turns off its engine. So the initial velocity of the scenario is 12 meters per second, right? Because we're solving the problem when the boat turns off its engine to when it actually stops, okay? And it drifts over a distance of 50 meters. So we know that the distance is equal to 50 meters. Okay, so what what other equation do you think you could use besides the second equation? I'm assuming when you say second equation, you're referring to the one on my screen, delta x equals v naught t plus 1 half at squared. If you're talking about a different one, you could probably just refer to my screen. It would be easier for calculations. So you guys said using a kinematic equation. So which kinematic equation do you think you could use? We already eliminated the second one because we don't need to find time. First one, okay, that's that's basically correct. The reason why I'll tell you is the third equation, you basically can't even use it because they tell you the distance. When they tell you the distance, you know you have to use an equation with delta x. You can't use an equation with the third one. And they tell you initial velocity, right? The first equation does have that. And they don't tell you time, right? They don't even ask you about time. And you don't even need to find time. So you don't even have to bother using the second or the third equation. You just jump right to the first one. Okay, does that clarify everything for you guys? How you select these equations? Yes, okay. Yes, okay. So after we got the first equation, right? What variable do we have to solve for? Look at the the givens that they give us and the variable that that we need to solve for. Which variable? Vf, v naught, a, which is acceleration, or delta x? Oh yeah, and just when they tell us that the pilot turns off the engine and drifts to a stop, you see to a stop, that tells us that v final is equal to 0 because it's when it starts and when it stops. So that's equal to 0 meters per second. What variable? A, okay. How about Rachel? Yeah, it is A. The reason why, right, you probably figured it out. Delta X, they already tell us, it's the 50 meters, right? The VF, they told us already, it's 0 meters per second. The V initial is 12 meters per second, which we already solved for. And conceptually, I also want to tell you guys why conceptually we need to solve for A. So remember I told you how like we link kinematic equations with Newton's second law? The one way we do this is through acceleration, because acceleration appears in kinematic equations and it also appears in the Newton's second law. So basically what we can do is do like substitution with acceleration. That's a key concept in AP Physics 1, because basically in AP Physics 1, all the questions are never on one discrete unit. It's never like, oh, one unit just on kinematics, or one question just on energy or momentum. It's like a combination of everything. And that's why you have to learn how to connect these concepts together in your brain, right? We learned about kinematics and now we finished dynamics, right? But you have to learn how to connect. How can I connect dynamics with kinematics? And that's using acceleration. So that's a key concept in AP Physics 1. The questions I've seen, they're all trying to combine all these problems together, like all these units, all these concepts. It's never on one specific topic. All right, so we know we need to find acceleration now. So why don't you guys go ahead and find acceleration? Negative 1.44 what? Don't forget your units. They're very important. Okay, yeah, negative 1.44 meters per second squared. Always don't forget your units. They're very important. If you make bigger calculations in the future, if you get like a negative 1.44, you'll be asking yourself literally, where did this 1.44 come from? Okay, so that unit is really important. Okay, how about Angeline? Did you get the same answer or a different answer? Okay, yeah. Yeah, I thought you were just like muted or you went somewhere else. So. What mistake do you think you made? Okay, why don't... Okay, found it, okay. Okay, yeah, Rachel, no problem. Also believe before you leave, Rachel, I just wanted to like to say something like about this like online program I made. It's called Teach Children STEM. I actually made it last summer, but basically right now our team is finding like passionate individuals who are going to high school who might be interested in like basically doing online activities with children. If you're interested in doing that, just let me know. Actually, you could I'll just put our website in here. And just basically go on the get involved page and then you can fill out a form there if you're interested in doing that. Yeah, that's basically something I just wanted to put out there. Okay, so Angeline, for now, do you understand where you got the negative 1.44 meters per second squared? Yes, okay. So the last thing we do now is we use Newton's second law, right? We know that the net force equals ma, right? And we know that the only force is the resistance force because the engine stopped, right? So we substitute as Fr equals ma. We know our acceleration and we know our mass. So you just multiply it together and you find your resistance force. So just plug that into your calculator and then I'll double check if it's correct or not. And I think that'll be it. Negative 5040. You're close. I think you probably made a calculation error in the 10th place. Checking again if it's negative 5040. I think your answer is almost nearly correct. I just feel like you did like a significant figure calculation wrong. Did you times anything by 10 extra? Yeah, -504. And don't just remember you put newtons because it is a force unit. And yeah, that's basically the end of the problem. So there's also a practice question. I'll post these slides later on Ed, and you can look at them. This is a actual AP style question. I think you can solve up to part D or E, and yeah, this is for your own sourcing. And as well as I said before to Rachel, there is this nonprofit not really an organization, but a program that I started last year as well as with my other team members. And we're also trying to develop a online initiative. So if you're really interested in like STEM fields or interested in doing like activities, specifically like DIY projects with children or just like being on our team, feel free to go on that website and just learn more about us and go on the get involved page, and the form will be there. Yeah. So I'll just end the meeting here then.